In this video, we're going to look at the product rule for exponents. For those who have a tendency to forget the rules, now is the time to learn them well. Beyond this point, the rules will never again be a problem in and unto themselves, but you will not be able to correctly arrive at solutions for future problems if you don't play by these rules. That being said, let's begin reviewing exponentiation and using that very basic understanding to develop our first rule. When we first learned about exponentiation, we learned that exponentiation occurs when you have a number that is being multiplied by itself. That number that's being multiplied by itself is what we call a base. And so in all three examples on this page, the base is 2. The exponent comes from how many times that base shows up as part of the multiplication problem, as a factor. Well, here 2 shows up as a factor twice, so 2 squared. Second example, 2 is a factor 3 times, so 2 cubed. Third example, 2 shows up as a factor 5 times, so 2 to the 5th. Very simple, very straightforward. But in this third example, there's another example hiding. If you look up here at the front, that is 2 squared. And sitting right behind it, I see 2 cubed. And so out of that third example, I get a fourth example that becomes a very good friend because he saves me a lot of time. Now, here's the rule. Take a look. And this is where the rule for the multiplication property of exponents comes from. Common base, always base 2. Answer, also base 2. So you got to be multiplying with a common base, and you're going to keep that base. So since I know what's happening with the base, let me drop the base out and look just at the exponents. 2, 3, and 5. Back to elementary school for a moment. How do you use 2 and 3 to get 5? That's right. You add 2 plus 3 to get 5. So it looks like you're going to keep your common base and then add your exponents to get the exponent on your answer. Could it really be that simple? Yes, it can. There is nothing magical about these examples that I created, so they'll work anytime. Let's pick an out there number, say 23 cubed times 23 to the 23rd. Now that last number is so big that you can type it in the calculator if you want to. It's going to overflow. You're going to have one of those times 10 to the numbers. So if I want an exact answer and you do it on the calculator, you're going to miss it. So how are you going to do it? You're going to say, well, I got a common base of 23, so that's the base in my answer. And then you're going to add the exponents. 3 and 23 make 26. And again, that number is too big for a calculator to handle. Stated very plainly, when multiplying exponential expressions with the same base, add the exponents. Use this sum as the exponent of the common base. Also, algebraically, that says the same thing. Now, why do I like the algebra? Because, see, I can say B is 2, M is 2, and N is 3, and there is exactly my example from the previous page. This also allows me to use it for our example with the base 23. It allows me to use it with base square root of 5. It allows me to use it with base B or base Z. So this is algebraically stated so that I can apply it to infinitely many cases. Now, for an algebraic example, multiply the expression using the product rule, x cubed times x to the 6th. Now, in Algebra 1, when you first started learning this, some of you, or 5th grade, some of you would write out all those x's and count them up. But we don't want to do that anymore because the numbers are going to get outrageous if we do. So, I multiply with a common base. I keep that common base. So, x is still going to be my common base, but all I have to do is add those exponents. 3 plus 6 is 9. End of problem. A little too simple? Yes, it is. And your problems in the future are not going to be anything like this. So, to be sure that you're a little bit better prepared for the future, let's work a few more examples. For instance, multiply the expression using the product rule, and then you've got these huge numbers. Okay? Now, here's where we come into some issues because students say, oh, but Ms. Harrell, I can't use the product rule because I don't have a common base. Well, actually, yes, you do, but you have to go back to elementary school again and borrow something from back there. If you'll remember from what those symbols all mean, the parentheses mean multiply. So the first thing I notice is that I have multiplication here, and I'm going to write out the little dots for multiplication symbols so that you can see all my multiplications. But the parentheses also just mean multiply. So here's the problem written out with all my multiplication dots in between them. Now, here's the thing. Notice, please, that everything up there is multiplication. There's not any additions, no subtractions, no divisions. Everything is multiplication. Back in elementary school, you also learned the commutative and associative properties for multiplication. Hopefully, you also learned back then that if you put those two properties together, you have the most powerful tool, and that is that I can multiply in any order I choose. So here's the order I choose. I'm going to take that 4 and the 7 and put them together. Then I'm going to take the x's, x to the 3rd and x to the 6th. I'm going to put them together. Then I'm going to take the y's, y to the 4th times y squared, and I'm going to put them together. Then I have, now the front one is not an application. 4 times 7 is still just 28, just like it always has been. But in these last two, I have two examples of the product rule. You put down your common base and you add your exponents. You put down your common base and you add your exponents. And all of a sudden, you arrive at your answer. Let's do that again. Again, yeah, I do kind of technically have a division, but let me remind you that any division, that 2 divided by 3 you see in that fraction, can be thought of as multiplication, okay? Dividing by a number is the same as multiplying by the reciprocal. So, I'm seeing nothing but multiplications up here again, and so I'm going to regroup. I'm going to multiply in any order I want, and I'm going to put my numbers together. I'm going to put my A's together. And then I'm going to go back and put my B's together. Now, for the numbers, little review from elementary school. That fraction bar means divided by, which is the same as times 1/3. So, I'm going to take 1/3 of 9 and call that a 3. Then 2 times 3 is 6. Okay? Now, you may not be that good with fractions yet, and I hear this every year, but you need to practice it. You need to practice it, especially on homework where it's not going to count so much. You need to practice it because you're also going to need to do it towards the end of the course with variables. All right, so then A is my base, and I add the exponents. 2 plus 3 is 5. B is a base, and 6 plus 2 is 8. And all of a sudden, that big, long problem didn't look so hard anymore. Okay? All right, now, while we're doing these problems, and I'm breaking apart and gathering things together, now that you've seen it a couple of times, let me tell you the goal. The goal is you want to be able to practice these problems enough to the point that you don't have to write out where you broke things apart and put things together. For instance, I want to just look at this and say 1/4 of 12. Well, 4 goes into 12 3 times, so 1/4 of 12 is 3. I want to look at this problem and say, oh, there's no a here, but there's a here, so that's just a cubed, because there was nothing to multiply him by. And then I want to look at it and say, then D, 8 plus 5 is 13. And there's my final answer with no work shown. Notice I did in my head exactly what we were doing when we wrote it down, breaking it apart. But you need to practice it until you get to this point where you can look at that problem and write out the answer without having to show your work. Good luck.